Welcome back to PA Academy. So this is the second part on the video series under Coulomb's law. So in the previous part, we looked at what Coulomb's law is, and we looked at the formulas and every other thing. All right, so this is the first example we are going to be looking at under Coulomb's law. So the question says a charge of Q1, and this is the charge 3 times 10 raised to the power minus 4 coulombs, is located at M, and this is the location, and a charge of Q2, this is Q2, and this is the direction, in a vacuum field. Now we are asked to find the force exerted in Q2 by Q1. So if you take a look at this question, you see that this is a question that has to do with the vector form of Coulomb's law. So a quick recap to when we look at the first one. So I said earlier that in the previous part I mentioned that you can either have this formula or this formula, but these two are not in the vector form. So but in this example now, we're going to look, this is what we are going to be making reference to. This is the formula we are going to be using because the question that we are dealing with now is giving us what? A direction. So that means it's in a vector form. So now let's write out the formula first. So that means the formula we have to use is to look for the force is, so that's F is equals to Q1 Q2 over 4 pi E naught, and then the magnitude of R12 square, so multiply by A12 over R12. Okay, so don't worry, that's our purpose of this example. We are going to simplify everything. So now let's bring out the parameters from the question. From the question, we have our Q1 to be 3 times 10 raised to the power minus 4 coulombs. We have our Q2 to be minus 10 times 10 raised to the power minus 4 coulombs. And then we also have our R1. So this is our R1 here, which is 1, 2, 3. And then for our R2, we have it to be 2, 0, 5. All right. So now let's start with calculating. So let's start with calculating the value of our R12. So in calculating our R12, so by this now, this is X, this is our X, this is our Y, and this is our Z. Okay, so what we are going to do is 2 minus 1. So 2 minus 1. So that represents for the AX axis, plus, so this is 0 minus 2. So that 0 minus 2, and for this it will be AY. Then plus 3 minus 5 AZ. Okay, so with that now we're going to, our R12 is equals to, so 1 AX, so 0 minus 2, that's minus 2, and then we have plus here, so that will be minus 2 AY. Then 3 minus 5, oh sorry, that should be 5 minus 3, not 3 minus 5. So 5 minus 3, and that would give us plus 2 AZ. So now that we've gotten our R12, so for this should be R0A, so let's note. So this is R12. So now we've gotten the value of our R12 to be this. So let me just put that. So then next, let's get the unit vector. So that'll be R12. And to get that, that's going to be the square root of 1 square plus minus 2 square plus 2 square. So we are picking the value from this. So if you are to do this, you are going to be having square root, that'll be 1 plus 4 plus 4. And that's square root of 9, and that's 3. So that means we've gotten our R12. So with this now, we can go ahead and put in those values in the formula. So again, So from the formula again, that which is F is equals to Q1 Q2 over 4 pi E naught R12 square, then multiply by R12 over the magnitude R12. Okay, so in doing this, so our Q1 is 3 times 10 raised to the power minus 4, which is this. So let me do it on a new line. So 3 times 10 raised to the power minus 4 times our Q2 is minus 10 times 10 raised to the power minus 4. So that will be minus 10 times 10 raised to the power minus 4. Then over 4 times, so we already know 4 pi, okay, let's just use pi, times, now our E naught, we are not giving the value of E naught, but we already know that from the previous video I mentioned it that it's the value of E, so let me just write it here, is 8.854 times 10 raised to the power minus 12, or you can use 1 over 36 pi times 10 raised to the power minus 9. So that's value, it's a constant. So you might be given in your question, and you might not be given, but you just have to take note of that. So let's use 8.854 times 10 raised to the power minus 12, then times, now R1, the magnitude of R12, which is, we've gotten to be 3, so that will be 3 square, and which is 9, or exactly. So multiply by our R12 itself. So our R12 is this, which is 1ax minus 2ay plus 2az all over the magnitude of R12, which is 3. Okay, so what's just left is just calculation. So let me type this into the calculator. All right, so if you put that into calculator, so if you go back to our question, this our Q2 is minus 10 raised to the power minus 4, not minus 10 times minus 10, so it's just minus 10 times 10 raised to the power minus 4. So let's take this out. So if you should multiply this now in your calculator, you are going to be getting minus 30. That means if you should do only this. So we are having minus 30, and then 1ax minus 2ay plus 2az all over 3. So that means our F. So one thing also you need to take note of is if you are calculating the force in terms of vector, make sure you add this bar at the top. Exactly. So this will be minus 10. So because this 3 will give us 10, that will be minus 10 into bracket 1ax minus 2ay plus 2az. So if you use that to open the bracket, you are going to be having minus 10ax plus 20ay minus 20az, and don't forget the unit will be in Newton, and this way that we are having right here is the force exerted on it. So now, like I said, if you are calculating the force in vector form, don't forget to add this bar. But if you are just asked to calculate the force and it's not in vector form, definitely you are going to be getting your answer to be minus 30. Exactly, just minus 30. So this is the first example we are going to be looking at under the Coulomb's law. So I hope you find value. If you do, please give it a thumbs up. And if you have any question or doubts, just let me know in the comments section below. So I'll see you all in the example 2.